You've seen them, right? These absolutely mind-blowing images that seem to pop out of thin air, all from just a few words of text. But have you ever wondered how an AI actually learns to paint with ideas? Well, today, we're going to dive deep into the game-changing paper on latent diffusion models. This is the tech that basically blew the doors wide open on AI art for all of us. Okay, so just check this out. The prompt? It was super simple. A painting of a squirrel eating a burger. And boom, this is what it came up with. I mean, look at the details here. You can almost feel the texture of the fur. And that soft light on the burger bun, the whole painterly style, it's a stunning take on a pretty silly idea.
But believe me, it gets so much weirder. What if you asked for, say, an image of an animal, half mouse, half octopus? Yeah, you get this. It's like something pulled straight from a surreal dream, but it's rendered perfectly. The AI's imagination is it's completely wild.
And you know, it's not just about making up weird creatures. This AI can actually understand and blend really complex artistic styles. The prompt for this one was The Last Supper by Picasso. Think about that for a second. A masterpiece that literally never existed, until now. An AI just dreamed it up. But, and this is a big but, this kind of magic used to have a huge hidden cost, a cost that was seriously holding the whole field back.
So how bad was it? Well, before latent diffusion, getting images like the ones we just saw was, let's just say, painfully slow. To get 50,000 sample images, you'd need a super powerful AI model running on one of the best GPUs you can get, and it would take about 5 full days. That is a ton of time, a ton of energy, and you guessed it, a ton of money.
And that brings us right to the heart of the problem that these researchers were trying to crack. It's all about the massive inefficiency of working directly with pixels. I mean, every single image is made up of millions of these tiny dots. Trying to train an AI to handle them one by one, it's just so incredibly expensive, power-wise, that it basically locked this tech away from almost everybody.
And look, I'm not exaggerating here. The researchers said it best themselves in the paper. This kind of AI was basically becoming this exclusive club, only for groups with these gigantic server farms. And on top of that, the carbon footprint was just huge.
So, the big question is, how do you fix this? How do you make this amazing technology faster, cheaper, and available to more people without making the images look terrible? Well, the answer was a stroke of genius, really. A huge leap. They decided to stop painting with pixels and start painting with ideas. And that is the magic of what's called latent space. So, what in the world is latent space? Okay, think of it like this. Like you're building a house. Working in the old way, in pixel space, is like telling your builder where to put every single brick. One by one by one. Yeah, it's super precise, but it would take forever, right? Now, working in latent space is completely different. It's like handing that builder the architect's blueprint. That blueprint has all the core ideas, the shape, the rooms, the style, all wrapped up in one efficient, compressed package. It's just a smarter way to work. And this is a perfect way to actually see the difference. So on the left, you've got this gorgeous, super detailed landscape, right? And on the right, well, that's its blueprint. That's what it looks like in latent space. Now, it doesn't really look like a picture to us, does it? It's more abstract. But hidden inside all that data are the core concepts. Mountain, forest, misty vibe. Everything needed to create that final image just squeezed down into this super compact form.
So that's the whole goal right there. That's the big idea. You train the AI to work with these efficient little blueprints instead of these giant, clunky pixel maps. And by doing that, you can just slash the amount of computing power you need, all while keeping the final images looking amazing.
Okay, so the idea is brilliant, for sure. But how does it actually work in practice? Well, the whole thing is this really clever two-step dance, with two different AIs basically working as a team.
So, step one is what we'll call the compressor. You can think of this AI, it's called an autoencoder, as like a master art summarizer. Its whole job, after being trained on millions of images, is to learn how to take any picture and shrink it down into that essential blueprint we talked about. Simple enough. Then you have step two, the generator. This is the creative one, the artist. This second AI, the diffusion model, is the one that learns how to dream up brand new blueprints based only on your text prompt. And once it's created that new blueprint, the other half of that first AI kicks back in and builds it back up into a full, beautiful, high-res image. It's a really elegant system.
So it keeps saying diffusion model, but what is that exactly? The best analogy I've heard is to think of it like developing a photo, but backwards. The AI starts with just pure static, right? A screen full of random noise. Then, using your text prompt as its guide, it starts carefully, step by step, removing that noise. It's like a sculptor chipping away at a block of marble until a clear, amazing image just emerges from the chaos. It's literally creating something out of nothing.
So, what was the payoff for all this cleverness? What did this two-step latent space approach actually get us? Well, to put it simply, a massive explosion in what these models can do and how efficiently they can do it. And what's really cool is that this powerful technique isn't just for making images from scratch. Nope, you can use the exact same idea for other super useful things, like intelligently editing photos that already exist. For example, take a look at this picture. This is something called inpainting. So let's say we want to get rid of that big tree, right? It's kind of blocking the view of the building. All we have to do is just draw a mask over the part we want to get rid of.
And check this out. That's the result. Now, the model doesn't just, clumsily delete the tree and leave a blank spot. It intelligently fills in that gap. It understands the building's architecture, it gets the lighting right, it matches the textures, it makes the whole edit look completely seamless. It's incredible.
And hey, it's not just our opinion that it looks better. The researchers actually proved it. They ran a study where they showed people edits from their new model and the previous best one and just asked, which one do you like more? The results were pretty clear. People preferred the latent diffusion model's work almost 70% of the time. I mean, that's not even close. That's a huge win.
This chart right here really drives the point home about efficiency. It basically shows image quality versus how long you have to train the model. Now, don't worry about the jargon. All you need to know is that for the quality score, the FID score, lower is better. Okay, so see that blue line way up top? That's a model chugging away in the old pixel space. Look how slowly it improves. Now look at those other lines down below, especially that red one. That one's working in the smart, efficient latent space. It gets a way better score, a much lower score, in a tiny fraction of the time. We're talking a massive leap in quality, way faster.
So what we're looking at here isn't just a small step forward. This was a genuine game changer. It completely rewrote the rules for AI-generated art, and while it opened up all these incredible new possibilities, it also brought up some really big, important questions we have to think about.
And to their credit, the researchers talk about this stuff right in the paper. This isn't just about technology. It has a real impact on society. So on the one hand, this is amazing, right? By making it so much cheaper and easier, it puts these super powerful creative tools in the hands of pretty much everyone. Artists, designers, you name it. But there's another side to it. They also point out the dangers. When it's this easy to make realistic images, it also makes it way easier for people to create convincing deepfakes and spread all sorts of fake visual information. It's a double-edged sword.
And that leaves us with one last really fascinating question to chew on. This technology, it has changed the game forever. There's no going back. So I'll leave you with this. When an AI can take a single thought and turn it into a masterpiece in the blink of an eye, what does that mean it means to be an artist anymore? What does the future of art even look like? Something to think about.